Washington, D.C., right? Usually everybody at some time says, somebody says St. Paul. You know, they get, like try to answer quickly, right? Capital of Minnesota, St. Paul, right? Who's the first president of the United States? Who's the second president? Who's the third? Thomas Jefferson. First and second hour didn't get, or second and third hour didn't get it, but that's kind of an important one too, right? And people start to fall apart if they don't remember them, but presidents kind of like a big deal. Number 16 was Abe, right? Abe Lincoln. Now, and so I'm going to show you a couple formulas that we try to remember some of these, but some of them fade. But just like everybody knows the capital of the United States is Washington, D.C., you have to remember our first formula. It is that important. You cannot forget it. And I will say that I would say usually in calculus, every single student but maybe one remembers it when they get to calc. Like, we need to know this. So what's beautiful about this day is that we are going to show you where all these come from. Please just insert a horizontal line somewhere right below that information, and let us generate some important equations in trigonometry. I started this course by saying that all trigonometry is based around one formula. Does anybody remember what that one formula was? The Pythagorean theorem. Thank you. A squared plus b squared is equal to c squared. And from there, we said, well, we want to talk about the unit circle, and we know a circle has a formula of x squared plus y squared is equal to r squared. And these two are truly the same formula, just switching of letters, but we have x, which is the horizontal leg, y, which is the vertical leg, and the radius is the hypotenuse. It's the same thing. And then we said if we're in the unit circle, the radius is 1. So you have x squared plus y squared is equal to 1. Well, yesterday we learned something pretty cool. That in trigonometry, instead of using y, what can you say instead? It's a trig function. Y is the same as sine. And x is the same as cosine. So I can write sine squared of theta plus cosine squared of theta is equal to 1. Other than the Pythagorean theorem, most important formula in all of trigonometry. Must remember this. Use it all the time. And see where it comes from? Right there. I didn't make it up. We've shown it all the way through. Now, just to be clear, so there's no confusion about the operation here, this is the same thing as taking sine of theta and then squaring it, and cosine of theta and then squaring that. Okay? But we don't put the squared over on the theta side because then it looks like we're squaring the theta. You see it? So when you see sine squared, that's what that means. Take sine of theta, then square it. That's what that means. You start to see how the English language is limited in expressing things mathematically sometimes. All right. There's another formula. Tangent of theta is equal to y over x. Well, considering what we just talked about, instead of saying tangent's y over x, what could we say? Tangent is, very good, y is sine of theta, and x is cosine of theta. I'm going to come up with the second most important formula, and I'm going to start with sine squared of theta plus cosine squared of theta is equal to 1. And what I will do is I'm going to divide through by something. And in this situation, I'm going to divide through by cosine squared. Can somebody guess what sine squared divided by cosine squared is? Tangent squared. Cosine squared over cosine squared? 1. 1 over cosine. What's the reciprocal of cosine? Secant. This is important formula number 2. This is number 1. That's number 2. You get these formulas on the test. I will give them to you, unless you would like to remember them on your own. Needed them and I just couldn't remember them, but oh well. Wanted the challenge. The third one is we start with sine squared of theta plus cosine squared of theta is equal to 1. And what we'd like to do here is, anybody know what we're going to divide by now? We're going to divide by sine squared. Sine squared over sine squared. 1. Cosine over sine. Cotangent. Rachel ate her Wheaties today. Actually, her chicken and mustard sandwich. Turkey. Gobble, gobble. 1 over sine. Cosecant. This is formula number 3. Along with that little tidbit we said where tangent of theta is sine over cosine. Keep those somewhere where you can reference them. They are of the utmost importance. Everybody okay? All right. Last thing we do is off to the side there. If you could please draw a nice coordinate plane, an x and y axis. It's the final thing we have to do, and then we'll be ready to go on Tuesday. But without it, we'll be lost. This is the first quadrant. This is the second quadrant, third quadrant, fourth quadrant. You said you already knew that. Good. Positive, positive for your x and y values. Negative and positive for your x and y. Negative and negative for your x and y. Positive and negative for your x and y. It turns out that sine, cosine, and tangent have values that are positive and some values that are negative. For example, if I'm working in degrees and I would press the cosine of 60, I get 1/2. Whereas I press the cosine of 120, I get negative 1/2. Why are some positive? Why are some negative? Let's understand. Sine is the y value. So will sine be positive or negative in the first quadrant? Cosine is the x value. Will it be positive or negative in the first quadrant? Cosine is positive. And tangent is y divided by x. Will it be positive or negative? Tangent of theta is positive. Talk with the person next to you as we move to the second quadrant. What do you think will stay the same, and what do you think will change? Take about 20 seconds to talk. Go. Five, four, three, two, one. Sine is the y value. Will it be positive or negative? Because it's the y value, it will be positive. How about cosine? Cosine will switch to negative because it is the x value. And tangent is y divided by x, so that will also be negative. As we move to the third quadrant, is sine positive or negative? Sine will be negative. How about cosine? Cosine will be negative. How about tangent? Should they all be negative, just like in the first one, they're all positive? Negative divided by negative is positive, so tangent is positive. And in the fourth quadrant, which is the only one that will be positive? Cosine is the only one that will be positive. Knowing where these trig functions are positive and negative is very important for Tuesday. There are 3 ways to remember them. 3 ways. First of all, you always look back at the sheet. which I think is a total pain in the butt. Like, I get it, it's nicely organized, but it's nice if we can find other ways to do it. I'll show you the way I do it, and I'll show you the way most of the students do it. The way I always thought of it was this. Sine is y, so it's positive up. It's negative down. Cosine is x, so it's positive to the right. It's negative to the left. Tangent is positive where they're the same signs. Negative where there's opposite signs. That's how I always thought of it. But some students, they use acronyms. Like acronyms, like for example, like here's the acronym that they use. All students. This might not be an acronym, might be like just some kind of association. I don't know. I'm not an English teacher. All students take calculus. Why do you think they put all there? They're all positive. Why do you think they use students here? Because sine is positive. Why take? T, tangent, is the one that's positive. And then C for calculus, cosine's the one that's positive. All students take calculus. That's a way to remember it as well. Certain things, like I never learned. When I was in high school, I know it sounds crazy, I never learned SOHCAHTOA. Never learned it. I always did just the right triangle trig another way. Never learned SOHCAHTOA. I remember I was first teaching calculus, and somebody said, well, yeah, all students take calculus. I'm like, actually, not all students take calculus. Like, no. I said, no, like, really, like, some people don't sign up the next year. Like, that's not what we're talking about, Mr. Gitz. I'm like, what are you guys talking about? They're like, well, our trig teacher last year told us, like, all students take calculus. I'm like, it's not true. Not all people take it. And then they explained it to me. I'm like, oh, okay. And actually, it was in the book. I mean, that's an acronym that people have used over the years, but use it if you want it. Okay. Is it true? All students take calculus? No. So I feel like I'm lying every time I say it. You know what I mean? It's kind of like Liar, Liar. You ever seen the movie? You've never seen the movie Liar, Liar? No. Anyway, so Liar, Liar. Jim Carrey, great movie, right? So it's like he falls this. He's habitual liar, right? But then he gets in a situation where he can't lie, he has to tell the truth. So like if he would like say that in class, he like wouldn't be able to finish the statement, would he? Yeah. Watch Liar, Liar. That's your assignment for the weekend. Watch a movie. Watch Liar, Liar with Jim Carrey. Report back.
Oh, it's by Jim Carrey. I have to watch it.
Yeah, it's great. You'll love it.